So far we have discussed about Coulomb's law. So in the first class we have discussed when we were talking about electrostatic fields, we discussed that the electrostatic fields are described by the two basic laws. One is Coulomb's law and the other one is Gauss law. So till the last video we have discussed Coulomb's law, using Coulomb's law and the various coordinate systems, how we can determine the electric field intensity. First, we determined how we can find electric field intensity due to point charge distribution, then electric field intensity due to line charge distribution, then electric field intensity due to surface charge distribution, and then electric field intensity due to volume charge distribution. And now here we will be talking about Gauss law. So we know that the Gauss law is applied when the given charge distribution has some symmetry. So if the given charge distribution has symmetry, it is very easy to find the electric field intensity by using Gauss law. So what Gauss law says? So Gauss law states that the flux flowing through the closed surface is equivalent to the charge enclosed by the surface. So statement for the Gauss law is flux flowing through the closed surface is equivalent to the charge enclosed by the closed surface. So that is psi equal to Q enclosed, where psi is the flux flowing through the closed surface and Q enclosed is the charge enclosed by the closed surface. We know flux psi equal to surface integral d bar dot ds bar. The charge enclosed within a volume or closed surface whose volume charge density rho v is Q equal to volume integral rho v dv. According to Gauss law, we can write psi equal to surface integral d bar dot ds bar equal to volume integral rho v dv. And according to um, divergence theorem says that divergence theorem says that the surface integral can be converted into volume integral. That is contour surface integral a bar dot ds bar equal to volume integral del dot a bar dv. So according to divergence theorem, surface integral d bar dot ds bar is equal to volume integral del dot d bar dv. So comparing the above two equations, that is 130a and 130b, we can write as rho v equal to del dot d bar, which is the Maxwell's first equation for electrostatics. Electrostatics in the sense time invariant fields. So this is Maxwell's first equation, del dot d bar equal to rho v. Now let us see the applications of Gauss laws. The one is the point charge distribution. So in the point charge distribution, so since point is a sphere, small sphere, assume that the point charge q is located at origin of the rectangular coordinate system as shown in the figure. Since it resembles sphere, we say that it is surrounded by sphere. So we say that the given distribution has spherical symmetry. So since it has spherical symmetry, we can use spherical coordinate system along with the Gauss law to determine the electric field intensity at any point P due to point charge Q. So uh, assuming the Gaussian surface as shown, and on the surface let us find the uh, uh, first the electric flux density. Once we get electric flux density, from which we can always find electric field intensity. So um, join the point P. P is on the surface of the Gaussian surface, uh, which is at a distance small r from the point Q. So the d bar equal to dr ar bar. So the normal the electric flux density will have the vector along the r direction. So d bar equal to dr ar bar, and the elemental surface on the Gaussian surface ds bar equal to, since it is perpendicular to r axis, definitely the surface will be lying on theta and phi axis. So ds bar equal to r square sin theta d theta d phi ar bar. So we have flux psi equal to contour surface integral d bar dot ds bar. Substituting d bar and ds bar, we get flux psi equal to integral phi equal to phi ranges. We know that phi ranges from 0 to 2 pi. Phi equal to 0 to 2 pi, and the co-latitude angle ranges from 0 to pi. That is theta equal to 0 to pi. Dr ar bar dot r square sin theta d theta d phi ar bar. So psi equal to dr integral phi equal to 0 to pi integral theta equal to 0 to pi r square sin theta d theta d phi, since ar bar dot ar bar equal to 1. So simplifying that, we get psi equal to 4 pi r square dr. So the charge enclosed by the charge enclosed by the sphere, it has only single charge, which is q, that is enclosed by the Gaussian surface. So q enclosed equal to q. So according to Gauss law, psi equal to q enclosed. So therefore q equal to 4 pi r square dr, from which dr equal to q by 4 pi r square, or d bar equal to q by 4 pi r square ar bar. And from this electric field intensity at point P due to charge q, which is at a distance small r, equal to E bar equal to q by 4 pi epsilon naught r square ar bar.